I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we'll discuss about angular velocity. In case you want to learn from me, you can always send an email on the address given. Let us try to understand what angular velocity is, and then we are going to take 5 most important questions on this particular topic. The angular velocity omega of a rotating object is the rate at which the central angle changes with respect to time. It is measured in radians per second. Angular velocity is also represented by revolutions per minute, RPM. The relation between the linear and the angular velocity is V equals to omega r. So these are very important things to remember. We say the angular velocity is change in angle, right? So if you have a circle here and an object is rotating, then basically the angle theta covered per second. So the angle covered per second. So angle theta in radians. Subtended per second. That is what angular velocity omega is, right? Now, based on this, we have 5 questions as you can see. The very first question here is, the hard disk in a personal computer rotates at 7200 rpm revolutions per minute. Find its angular velocity. So whenever we say angular velocity, the units will be radians per second. 4 choices are given to you. You can answer this question. The second question here is, find angular velocity of the seconds hand in the clock. Again, there are 4 choices. Here are the other 3 questions. Now this is a challenge question for you, which is a cycle with tires 70 centimeters traveling at constant speed of 15 kilometers per hour runs over a fresh paint strip. It has a fresh paint spot on the tire. What is the velocity in meters per second? So that is simple conversion from kilometers per hour to meters per second. Part B is find the angular velocity omega of the paint spot. So you can use the formula V equals to omega r to find this particular solution. And question number 5 is model the vertical height of the paint as a function of meters to second. That means distance traveled by the bike with time. You have to find meters is the height of the paint in seconds. Assume that the paint spot is at the bottom of the tire initially. So in this particular situation, we'll assume that if that is the bike, right? So let's say we got the paint here. So it moves. We'll model the height of the paint with time and distance covered. So that is the question. So based on your knowledge, I'd like you to answer these questions and then look into my suggestions. I'll actually provide you with very simple answers to all these questions. The very first question here is, the hard disk in a personal computer rotates at 7200 revolutions per minute. Find angular velocity. So when we say angular velocity, we mean omega in radians per second, right? So that is what we need. So let's see. Is basic conversion of units. 7,200 revolutions per minute. That is given to us. Now, one revolution is 2 pi radians. So we can write 2 pi radians is one revolution. We want it in seconds, so 1 minute will be 60 seconds, correct? So clearly from here, you see that the unit conversion, revolution cancels with revolution, minutes with minutes. So the units remaining are radians per second. Do you see that part? Radians per second. So that's what you need, right? And as far as the numbers are concerned, what do we get? We get 7,200 times 2 pi divided by 60 radians per second. You see that? So simple as that. That is what we could do it. So using your calculator, 7,200 divided by 60 times 2 times pi gives us the answer, which the exact value could be 240 pi, correct? Radians per second. So that is how you could actually answer this particular question. So I hope it is absolutely clear, right? So as far as choices is concerned, in part A, 240 pi radians per second, option C is the correct option. Question number 2 is find the angular velocity of the seconds hand in a clock. So in a clock, in 1 second, how much does it move? That is what you need to figure out, right? So the seconds hand, let's say starting from here, will move 1 second. Do you see that? It will move 1 second. Now, so think like this is like within, it takes 60 seconds to move the full circle, right? So 2 pi is the radians, and that circle is done in 60 seconds. You could think like this. So one full circle, it goes through in 60 seconds. So what is the angular velocity? Angular velocity is radians per second. It's a matter of simplifying this, right? So we can now write this as 2 pi radians per 60 seconds. That is the time taken for one full circle, right? For the seconds hand. You can simplify this and write this as pi over 30 radians per second, correct? So that gives you the option, which is option D in this particular case. So I hope you understand this fact. So it just moved 1/60th of the whole revolution in a second. Now let's look into the next question, which is a cycle with tires 70 centimeters traveling at a constant speed of 15 kilometers per hour runs over a fresh paint strip. It has a fresh paint spot on the tire. What is the velocity in meters per second? So that is conversion. We have 15 kilometers per hour, and we know there are 1,000 meters in 1 kilometer. As far as seconds are concerned, in 1 hour, we have 60 times 60 or 3,600 seconds. So kilometer cancels, hours cancel, you're left with meters per second as expected. Now you can just multiply and get your answer. So 15,000 divided by 3,600, correct? So 15,000 divided by 3600 gives you 1 over 6, which is approximately 4.16 meters per second, right? Now, the options given to us are 4.2 is closest, so option A is the right option. We can round this to 4.2 meters per second. Now it says that find the angular velocity of the paint spot. So since it moves on the tire, now it is going to go up. This tire is given to us 70 meters or 70 centimeters, correct? And it's moving. Now, the angular velocity and omega is related with the linear velocity as velocity divided by r. That is the relation. Since the radius is half of 70, 70 is the diameter, 70 centimeter cycle with tire 70 centimeter, that is diameter. So the radius is half of 70, and in meters per second we have the value which is 4.16. We can write this as 4.16 rounded to 7 divided by the radius, which is 0.35, half of 70, converted into meters. That is kind of important, right? So we have 4.16 divided by 0.35, and that gives us 11.9 radians per second. So you can use this relation. So remember, V equals to omega r, or you could rearrange and write omega is V over r. So that's the relation to remember to convert linear velocity into angular velocity. Now fifth question here is, model the vertical height of the paint as a function of meters to second. So height will be in meters and time in seconds. Assume that the paint spot is at the bottom of the tire initially. So it picks up the paint from here. So that means we could use cosine function, right? So if you see that, that becomes the axis, correct? So axis is 0.35 meters high. So it's good to write this all in meters. And that is the amplitude also. So that is also the amplitude. So we can write that the height with respect to time in meters is, since we are starting from the bottom, it is minus the amplitude being 0.35. Is good to take cosine function cos. In general, the equation is cos omega t, since the uh, phase shift is considered with a negative sign. So normally it will be cos omega t plus the distance of the axis above, which is also 0.35. And since we know what omega is, which is 11.9, we can write this as 0.35 cos of 11.9t, right, plus 0.35. So that gives us the equation for calculating the height of the paint spot at any instance of time, correct? So looking into our options, so this option is given to us. Option A was correct for fourth, and here also it is option A, which is the right option. So with that, we come to an end of this particular exercise, and I hope that helps you to understand how easily we can actually solve questions related to angular velocity. Feel free to write your comments and share your thoughts about this particular video. And if you have any questions, you can send it to my email or write some comments on our website at globalmathinstitute.com. Thanks for your time and all the best.